Hello and welcome to episode 5 of this series. In this episode, I want to explore different types of joins and how we can, query and fetch some data from more than one table using joins. So if you remember in the previous episode, we talked about primary keys and foreign keys, and we saw how we can make a relationship between a parent, table and a child table, like for example, a passenger table and a booking table. Now that those tables are linked, we can fetch data from those two different tables and kind of link those different records together to make meaningful queries. And I am going to show you how it's done in this episode. But before I do that, I need to explore the concept of joins. So as the name suggests, joins allow us to join or link two different tables together. So, given there is a meaningful relationship between the records inside of two tables, we can join them together based on the parent, primary key and the child, foreign key, and then we can, kind of materialize our records, the query result that we want. So let's get started. In this episode, we want to deepen our understanding of different types of joins, and we are going to see how we can combine data from different tables. But before we get to the code, and we are going to see a lot of code in this episode, by the way, let's talk about joins a little bit. So a join, as the name suggests, is used to combine rows from more than one table, from two tables, sometimes three or even more, based on some related column, like for example, primary key and foreign key. Take a look at this very simple example. So we are going to select all of the rows and all of the columns from the passenger, table, and we know that there is a relationship between the passenger table and the booking table. So for each passenger, there could be some, bookings, right? So the passenger is the parent, if you will, and the booking is the child. Now, in the passenger table, we have details for a passenger, and in the booking table, we maintain the details for bookings. But we want to link them together. We want to kind of join these two tables together, join the records inside of these two tables together based on two columns that establish the relationship between the records. And those two columns are the primary key in the passenger table and the foreign key inside of the booking table. So if the value inside of the passenger ID in the booking table matches the value inside of the passenger ID in the passenger table, we have a match. We have a linked, record. So we can be sure that that specific booking is for this specific passenger, and we fetch that record. We get the details for the passenger from the passenger table, and the details for that specific booking from the booking table. And we're going to see this in action. So this is the basic idea behind joins: linking records from more than one table together based on some condition. And take a look at the syntax. Select star from passenger, join on the booking table on this condition. So the value in this foreign key must match the value in this, primary key. Now, different types of joins exist, and we are going to explore them one by one. The first one is inner join. So inner join means match only where both sides exist. Let's talk about this. Again, with that example of, booking and passenger, suppose we want to keep rows where there is a match in both tables. We want to only show the passengers who have a valid booking, at least a valid booking. So think of it like this. Give me passengers who have made a booking. So from the first table, as you can see here, we are only keeping the rows where there is a match in the second table or in both of the tables, right? From the passenger table, show me the passengers, but not all passengers, only the passengers who have a valid booking in the booking table. So take a look at this example. We are fetching the first name from the passenger and booking ID from the booking table, and then we are creating a table alias. I am going to explore the table alias here. So we are going with a shorter name for the passenger table. Whenever I say P period, I mean passenger table, that period. So from the passenger table, we are going to get the first name. From the booking table, we are going to get the booking ID. And this is the way we create a table alias for the booking table. We are using inner join. Previously, we were using join, right? We are using inner join. We want to fetch the passengers who have a valid booking, and then on the same condition. So P, the passenger ID, and B, which is the booking table, the passenger ID. So for example, from the passenger table, we get the name, the first name, and then from the booking table, we get the booking ID. So if there is a passenger here that doesn't have a booking, we are not going to show it. We are going to show only the passengers who have made a booking. So again, think about inner join. Give me the passengers who have made a booking. Only keeps rows where there is a match in both tables, booking and passenger. Number two, the second type of join, left join. In left join, you are keeping all records from the left table, even if there is no match in the second table or in the right table. So keeps all rows from the left table and adds data from the right table if there is a match. If there is no match, we are going to show null. Let's take a look at example. So lists all passengers regardless of their bookings, and if they have a booking, show the details of that booking. If they don't have a booking, just show null. So again, select first name and booking ID from passenger P, right? We are creating a table alias name for the passenger table, and left join, meaning that we want all the passengers. But if there is a booking for that passenger, go ahead and show it. Based on the same condition, passenger IDs must match, but because it is a left join, if a passenger doesn't have a valid booking, no worries, we're going to show the name as well, but for the booking ID, we're going to show null. So take a look here. We have all of the passengers from the left table, and we are going to show their bookings. If for a passenger there is no booking, we are going to show the name of the passenger, but for the booking, we are going to show null. So again, Charlie is shown even though he has made no booking. But for the booking ID, we are going to show null. Think about it. In inner join, if the passenger doesn't have a booking, we are not going to show it. In left join, we are going to show that user, that passenger, even if it doesn't have a booking, and we are going to show null for the booking. The next type of join is right join. So we are going to keep all from the right table even without a match. So I am going to go through this as well. It is very similar to left join, but it is kind of flipped. So we are going to keep every row from the right table, and if there is a match in the left table, we're going to show it. Otherwise, we're going to show null. As an example, show all bookings, and if a passenger exists, show their names. We know that there is a relationship between the passenger table and the booking table. So the passenger is the parent because it has the primary key. The booking is the child table because it has a foreign key, right? Now we want to start from the child table, from the bookings table. And then for each booking, remember bookings are child rows. For each booking, we want to show the passengers. And if there is no passenger for that booking, we're gonna show null. Again, we're going to get the first name and booking ID, this time from the passenger, and then we are going to right join on the passenger ID from the booking and the passenger. Again, we're going to show all bookings. If for a booking there is no passenger, we are still going to show it, but for the passenger name, we're going to show null. So again, shows bookings 999, even though the passenger is missing, probably deleted. The next type of join is full outer join. So we are going to show everything from both sides. Keep all rows from both tables. Show null if no match is found on either side. Think of this like this. Show everyone and everything, even if they don't match. So again, We're going to fetch first name and booking ID from passenger, and we are going to full outer join with the booking table on passenger ID. Again, Alice has a booking. Let's go and show Alice with a booking. Charlie doesn't have a booking. No worries, we're going to render null for the booking. This booking has no passenger. Maybe the passenger got deleted. No worries, we're going to show the booking and we're going to show null for the passenger. So full outer join, it's kind of like a combination of left join and right join. Cross join, all possible combinations. Every row in table A is combined with every single row in table B. Kind of pair every passenger with every booking. It is used mostly for comparison reasons. So we are going to say select first name and booking ID from passenger P and cross join it with booking table. So for example, for Alice, take Alice and combine Alice with every single booking. So we've got two bookings. The next one, take Bob and combine Bob with every single booking. We've got two bookings. So this is called cross join. Used with caution. As you can see, it can return a huge number of rows. It is used mostly for comparison. So different types of joins inside of the table, we kind of talked about them. I am going to, skip this table. You can pause the video to study this yourself. So basically this table contains all of the things that we discussed about, inner join, about left join, right join, and full outer join, cross join. There is another type of join called self join that I don't want to explore here. It is used for joining a table to itself. Maybe in future episodes I will come back and give you an example of self join. Now, because we want to see these different types of joins in action, we need to add some data to our database. So in the subsequent sections of this series, of this episode, I am going to run some scripts to insert some sample data into our database. So some, bookings, some passengers, and then I am, of course, going to respect the foreign key constraints that we have created. And then we are going to query, the data that we have inserted in the table. So now let's get started with, inserting some passengers. So as you can see, we are going to use the insert into command to insert, some passengers into the passenger table. So I am going to, create a new query, and I am going to write this piece of code to create some passengers inside of the passenger table. And of course I have chosen, airline reservation DB, the database that we have, and I can go ahead and execute this, and 3 rows will be inserted for me. So let's continue. The next thing that I want to do is to insert some airports. Again, I am using the insert into command, as you can see here, and I am using, these 4 columns to insert some, airports. So again, let me get to this query and write my insert into command and insert some, airport information in the table core.airport. So I'm going to execute this, 3 rows. The next thing that I want to do is to insert some fare classes. Again, as you can see, I am inserting 3 different fare classes. And the next thing that I want to insert is, flights. So we are going to create 2 flights. So let me go ahead. Let me get rid of this one. I am going to insert my fare classes. So insert, execute this. And as I said, the next one will be, inserting some flights. flight number, departure airport, arrival airport, departure time, arrival time. So we go ahead and execute these as well. Let's create some bookings as well for, some passengers and some flights, right? So these are the, as I said, the foreign keys inside of the booking table that link each, record to a passenger and a flight. So because we have already created the passengers and the flights, we can create bookings for those passengers on those flights. And we are going to create the, fare class as well. So as you can see, I am respecting the referential integrity that I discussed previously. So I'm going to create, two bookings. And the bookings also identify the name of the passenger, the departure airport, and the arrival airport alongside the fare class. So let me go ahead and execute these as well. Then we can insert some cancellations, for example. So again, the booking ID that we created above with the reason for that, cancellation, and then we can insert some bookings. For example, the old booking ID and the new booking ID. Again, these are booking IDs. So these are, the booking ID and the flight ID. So it says that Jane with booking ID number 2, the first column is the booking ID, gets rebooked to flight 1. So we inserted some flights previously, right? So these are the flights that we have. We are creating, one cancellation because the user kind of requested a change. So, and then we are going to kind of create a booking. We can also go ahead and create some frequent flyer memberships. We created this table, I guess, in episode 2. So we've got, for example, for passenger ID number 1, the loyalty tier is gold. For passenger number 2 is silver. So let me go ahead, create the cancellation, the rebooking, and the membership. So the first thing we want to do is to create the cancellation. Then I want to create the rebooking. And then I want to create the membership for frequent flyer. So now let me go ahead and execute these. The rows are inserted. Let me continue. Now, before I start writing the queries using joins, I want to talk about table aliases. And I have kind of told you what table aliases are, but let's talk about them in more detail and then start writing queries and query the data that we just inserted. Table aliases, as the name suggests, are short names for the tables that you use in your queries. So yeah, table aliases, as I was saying, are short names given to tables in a query, and they're usually 1 to 2 letters, and they are going to be used as a nickname for a table name. Because if you do not create table aliases, you would have to write the full name of the table multiple times, and that makes the code very verbose, and it will make your code difficult to understand. Let's talk about a simple syntax example. So inside of the from clause, you can specify the name of the table core.passenger, and then specify a table alias name, so P. That means that from now on, when you write P and then period, it means that you are referring to core.passenger. So basically, P is going to be a table alias name or a nickname for core.passenger. Here, P is an alias for the table core.passenger. Why do we want to use table aliases? There are multiple reasons. First and foremost, it makes your queries shorter and cleaner. So instead of, for example, writing the full name of the table and then the name of the field or column, you can write p dot first name because you have, kind of created a nickname for core dot passenger table. So instead of writing the full table name every time, you can write the nickname or the alias and then the name of the field. So this, of course, makes your code shorter, easier to understand, and especially if the name of the table is too long and you want to, repeat it multiple times, it makes the code easier to understand. Another thing is that it avoids ambiguity when you want to join tables. So we know that when we are joining tables, more often than not, we are using the same name for the fields. For example, passenger ID, suppose it's like a primary key inside of the passenger table, and it is at the same time, a foreign key inside of the booking table. So the booking table and the passenger table, both of them have a field called passenger ID. So this creates ambiguity. So when two or more tables have columns with the same name, right? Like for example, passenger ID in booking and passenger. Aliases allow you to specify which table you are referring to, which column in which table you want. So with p dot passenger ID, if you have created this nickname for the passenger table, this means you want to, refer to the passenger ID column from the passenger table. B, if it is a nickname for the booking table, b dot passenger ID means that you want to refer to the passenger ID column in the booking table. So again, avoids ambiguity when you want to join tables, because when you are joining tables, you are referring to the names of columns that more often than not have the same name. Improves readability. So when you come up with nicknames or aliases, it can make your complex queries easier to understand and read because you are, basically typing fewer keystrokes. So from core.booking, from now on, when I say B, I mean core.booking, join it with core.passenger, and from now on, when I say P, I mean core.passenger table. And then when you want to, apply the condition for the join, you just mention the nickname and then the name of the fields, which, as I said, are the same here. So it's clear which table each column belongs to. Now, if you do not choose aliases, you would have to write a lot of code. So you need to, specify the schema and then the name of the table, booking, passenger, and then the name of the, let's say the fields, right? It is, of course, more explicit because you are specifying the full name of the table in addition to the schema, but you'd have to write a lot of code, and it makes the code unnecessarily, verbose and difficult to understand. So inside of the, from clause, you can specify a nickname, and inside of the join clause, you can specify another nickname, and then when you are, working with the names of the fields, you can refer to those aliases or nicknames. Again, that reduces the amount of code that you have to write and the amount of the code that the next developer has to read. So notice how long the table names are repeated every time. It's a bit harder to read and, of course, more typing. But with aliases, again, you are, creating an alias here, you are creating another alias here, and then you are referring to your aliases. Here, as I told you, aliases are usually one character in length or two characters. So if I can, specify the name of the table uniquely with one character, I'd go with one character. If I need to, have two characters, I'd go with two characters. We use B as an alias for booking table and P as an alias for passenger table. Why aliases help a lot in joins? Again, as I told you, when you're joining tables, you often use columns with the same name, like for example, passenger ID, primary key in one table, foreign key in another table. So aliases help you say b.passenger ID, p.passenger ID. Meaning, for example, for b.passenger ID, you mean the passenger ID, which is the foreign key inside of the booking table. And passenger ID with the P means the primary key column inside of the passenger table. So without aliases, the query becomes longer and harder to follow because due to the same name for the fields, you'd have to specify the full name of the table with the schema. So core.booking.passenger ID, core.booking, core.passenger.passenger ID. Now let's go through some examples, some query examples where we are going to kind of, create some queries with joins and see a lot of things in action. So let's take a look at the first example. We are doing a small, inner join. So if you remember, inner join means take everything from the, first table, the left table, join them with the records in the, second table, from the second table or the right table, and only fetch the records that have a matching record in the right table. So we are taking from the, booking table, we have aliases here as well. We've got, the booking table, the passenger table, two aliases. From the booking table, we want the booking ID and the booking date and the status. And from the passenger ID, we want the first name and the last name. And we are joining on the primary key and the foreign key. Remember, passenger ID in P or passenger is the primary key. Passenger ID in booking is the foreign key. So what is this doing? It is joining the booking table with the passenger table. So this is the parent table and the child table. So in the booking table, we have a foreign key that links a record to a record in the passenger table. So we would say that the passenger table could be regarded as the parent and the booking as the child. So this returns the booking ID, as I said, the booking date and the status from the booking table, along with the name of the passenger. And because we're using inner join, we're only showing rows where a booking has a matching passenger because of the inner join. So the use case for this query would be to show the booking history along with the name of who booked that that booking. So if, for example, for a booking we do not have a matching passenger, we're not going to show it because we're using inner join, right? So inner join means kind of fetch the records from the first table along with the related records on the in the second table. But if there is no record for a specific item in the first table, don't show it in the result set. So what I am going to do is to get rid of this code. By the way, guys, if you want to get the queries that I'm running, I have included all of them in the repository for this playlist, and the link to that repository on my GitHub profile is in the description of the episodes. So just clone the repository, take the code, the scripts that I'm running here, and test and try them on your machine. So let me write the code that we created, that we talked about. Again, as you can see from the booking table and the passenger table, we type aliases, we're fetching these columns, and we're inner joining them, right? We're inner joining them with the passenger ID. So let me run this query, and you see that for these two bookings, we've got two passengers, and we've got the booking date, and the status is confirmed. So if there is a booking that doesn't have a passenger associated with that booking, we're not going to see that booking here. So we're only going to show the bookings who have a passenger, a related passenger. And of course, it doesn't make sense to have a booking that doesn't belong to a passenger, because again, I told you that the passenger is the primary, let's say, table, the parent table, and the booking is the let's say, the child table. Now let's continue. The next query is going to list flights and the departure and arrival airport names. So again, we aren't using different tables. We are actually joining different tables here. So we've got aliases for flight table. We've got this alias, and then we've got the airport code. Airport tables with two aliases, A1 and A2. And the reason is that we not only want the departure date, the departure airport, but we also want the arrival airport. So let's take the flight number from the flight table and the name of an airport from the airport table with this alias. And when we say as, it means that we are going to create an alias for this column. So if we do not type, departure airport, the name of the column is going to be name. But when we say as departure airport, in the result that we get from our query, the name of the column is going to be departure airport. And then we've got, the arrival airport from A2. A2 is the alias for, again, the, airport table. So for the airport table, we have two aliases, A1 and A2. So we kind of have two different, let's say, references to this table. So from the A2, we want the arrival airport, and then we want the departure time and arrival time and departure time are inside of the flight table. And then we are, creating this alias for the flight. Now let's join things together. So if I take you to the table, just let me show you something before I, continue with the, let's say the code. So if you take a look here, right? If you take a look here, for each flight, we've got departure airport and arrival airport. These take us to the, information of an airport which we have inside of the airport table. So here. So you see this airport code here. This is the primary key here, but these are two foreign keys. So for each flight, we are referencing the departure airport and arrival airport to the airports we have defined here. So basically, if we want to get not only the departure airport and but also the arrival airport, we kind of need two instances of this table, right? So one for getting the departure airport and one for getting the arrival airport. So that is the reason why we are doing two joins, as you can see here. So to get the departure airport, we are going to, join with airport table using this alias, and then we are checking this condition. The departure airport, this is the code of that airport, should match the airport code coming from the, airport table. And we're doing the same thing for the arrival airport as well. So the arrival airport and departure airport, as you can see inside of the flight table, both of them take us back to a record in the airport table using that airport code. The airport code in the airport table is the primary key, and these two, the departure airport and arrival airport in flight table are the foreign keys. So foreign keys and primary keys, we are going to compare them. And because we need the information of both the departure airport as well as the arrival airport, we need to do two joins, right? And that's the reason why we are creating two aliases. We want to refer to them separately. So what it does, again, as I explained, it joins the flight table with the airport table twice, once for the departure airport, another one for the arrival airport, and it shows each flight's number, departure and arrival airports based on the, joins, and the timings which are inside of the flight itself. So inside of the flight, this is the flight table. We have the time. We do not need to join, with another table for the time. But for the departure airport and arrival airport, we need to join with this airport table based on this primary key. Again, I reiterate, because we are going to fetch the details of these two airports, we need two joins, one for departure airport and another one for the arrival airport. So I am going to remove this, and I am going to write the code. I think one of the key takeaways of this code is that you can refer to the same, table using different table aliases. If you require something like that for, doing two joins, it is absolutely possible. So you're not limited to only having, one alias for a given table. You can create more than one, table name alias. Now let me run this. So we've got the flight number, we've got the departure time and arrival time coming from the table itself, the flight table. And do you remember the names of the fields? These are the aliases for the names of the fields: departure airport, arrival airport. And then we are joining the airport codes with the names of the airports. So if you remember from the from this table, this is the primary key. It's a 3-character key, but we've got the full name of that airport as well. So let me show you the data. So you see the airport code. These are the primary keys here, and inside of the flights, we have the same thing but as foreign keys. We can go ahead and only show the codes for each airport. But if we want to be more user friendly, it is better to show the full name of that airport, the airport that these codes represent. In order to do that, we need to join this table with this table and this airport code. So that'll give us the name, the full name of that airport, of that departure airport and arrival airport. And that is what we get here. So not this one, here. So we've got the full name of the, not this one, this is the, I guess, yeah, this one. We get the full name of the departure airport and arrival airport, not only the, airport code. So let's continue with the next, example. We're going to show all passengers and their loyalty tier. So again, we need to make a join from the, passenger table and the frequent flyer table. Again, let's take a look at the table. This is the frequent flyer. You see this passenger ID. This is the foreign key that takes us to a passenger. So from one record in the frequent flyer, we can join the passenger ID with the passenger ID we have here, right? And for each passenger, then we will be able to get the first name and full name, as well as the loyalty tier. So let me close out these, and I'm gonna go ahead and take a look at the code. So passenger ID, passenger name, first name coming from the passenger table. Loyalty tier coming from the frequent flyer. And the passenger ID primary key, foreign key. This is the foreign key, this is the primary key. And we're doing left join. You remember left join, right? So left join means for each passenger, in this case, from the left table, take everything from the left table, even though they do not have a matching table in the right table, which is the frequent flyer. If there is a match, show it. If there is no match, just show null. So return a list of all passengers. For each passenger, it tries to find a matching frequent flyer record. If it finds it, it's going to show the loyalty tier. Otherwise, it's going to render null. So this is possible because of the left join, as I told you. It keeps all passengers, even those without loyalty membership. So let me go ahead, get rid of this, and write this code. Remember the difference between the left join and inner join. So inner join only shows the records that have that have a match on both sides of the join. But the left join shows everything from the first table, and if there is a match on the second table is this. It's going to show it, otherwise it's going to render null. So as you can see, for this passenger, we have no loyalty tier. So it's going to render null here. Use case, show who is enrolled in the loyalty program and who isn't. Count bookings per flight. So we are going to do a simple aggregation. I'm going to talk about aggregation functions, in future episodes. We are going to do a left join. We are going to do a group by. Again, I am going to talk about group by as well. This is just, a simple example to kind of get you started. on the concepts of group by and the aggregation functions. So we are going to take the flight number. Remember, we want to count the bookings for each flight. So a booking can be associated with a flight. So if you, for example, get let's say a flight, so we've got the flight number and the flight ID, right? The surrogate key. Now, if you take a look at the booking, for the booking, we've got the flight ID. So each booking can take us back to a specific flight ID. Now we want to count how many bookings we have for a given flight. So for example, for let's say this flight number 1, we've got 1 booking. This is the only booking for this flight. For the flight number 2, we've got 1 booking. So 2 bookings, 1 for flight ID 1, 1 for flight ID number 2. So let's take the flight number and let's count the booking IDs from the booking table. This is the table name alias, and let's name the column booking count. So we are going to have 2 columns, right? Flight number and a booking count, and the booking count is going to be the count of b.booking ID. What is b? B is an alias for the booking table. So from the flight table, let's call it F from now on. Let's left join it with booking. Let's call booking B from now on, and let's match them on the primary key foreign key. This is the primary key, this is the foreign key, and let's group them by the flight number. Again, we want to count the number of flight numbers. If there are, for example, more than 1 booking for the same flight, we want to group them. And for example, in the result, see flight number 1 and then a number showing the number of records inside of the booking for that specific flight. Again, I am going to revisit group by and count in future episodes. So for each flight, we're counting how many bookings it has. We're using left join again. So flights with 0 bookings that still appear, we get all flights, even though even if they do not have a booking. And we're using group by to count per flight number. So let me go ahead, let me close out this one and this one, and I am going to remove this one as well and write not this code, but this one. Now let's run this, and as you can see, we've got different flights, and for each flight we've got the booking count. So as I showed you, we have 2 bookings, and each booking is for one of the flights that we have. So the name of the flight number as well as the number of the bookings. So useful for reporting how many passengers have booked each flight. Before I let you go, I want to give you a challenge. And I have written the code for this challenge myself. You can find it in the repository as well. I'm going to show it to you as well here, but I highly recommend you pause the video for a second and try to give it a shot and see if you can solve this challenge. That'll give you a good chance of practicing things. So the challenge is very easy. I want you to create a table called reward point, and I want to link that to frequent flyer. There is going to be a one-to-many relationship. So one membership can have many reward entries. Remember, for frequent flyer, we can link 1 record from the frequent flyer to 1 passenger ID. But again, for a membership in frequent flyer, we can have as many reward points as we want. So there's going to be a one-to-many relationship between the frequent flyer and the reward point. And each entry should include these information. So we want to have the point ID as our surrogate key, membership ID as our foreign key. We want to have an integer with this check constraint, points earned, and another one, earned date default to current UTC date time. So again, give the video a pause, give this challenge a shot, and I hope you can solve it. It's not that difficult. And I think it will give you a good chance to get your hands dirty and practice the stuff we have been talking about. So now let's go through the code. We are going to create a table, as you can see here. The table is going to have the point ID table as our surrogate key. It is also our primary key. The membership ID is going to be our foreign key. It cannot be null, not null. The points earned is not a foreign key. It is integer. It is not null, and it has to be greater than or equal to 0. So the check constraint. And then we've got the earn date with a default value of system UTC date time. It cannot be null. And then we've got this foreign key constraint. So we are creating this constraint called foreign key reward point membership ID. The foreign key table, the foreign key column is membership ID, which we defined here, right? And it references to the frequent flyer table and the membership, column, which is the primary key in that table. Now let's continue. Let's see this table now. Then we are going to insert, as you can see, some values to insert some values into this, reward point table. So let me go ahead and create this table. I'm going to remove this code. Let me create the table. So this is the definition of this reward point table. And then let's seed the database. Let's seed this table. Some values for a frequent flyer membership. We are not specifying the value for the surrogate key because that is going to be auto-generated by our database, but we are specifying the values for this membership foreign key, which takes us back to a record inside of the frequent flyer. So let me execute this. The table is created. Let me insert the values now. So I'm going to get rid of this code and continue with the notes. Now we want to write a select statement that returns total reward points per passenger, including those with no points yet. So remember, we've got our passenger table. This is the passenger table, right? This is the primary key here. And then we've got the frequent flyer, which has a foreign key for a passenger and a membership as our primary key. And we've got our, let me refresh this. We've got our reward point, which has this membership as the foreign key, taking us to the frequent flyer. So these three tables, frequent flyer, reward point, and the passenger are related. So there's a relationship between them. Between the reward point and the frequent flyer, the relationship is established using this membership field. And between the passenger and the frequent flyer, the relationship is established using the passenger name, passenger ID. I'm going to close everything. I don't want to save anything. And I want to create a new query. Now let's get to the code. So we are going to select the first name and last name from passenger, P, right? P is the alias name. And then we want to left join with frequent flyer on the passenger ID because the frequent flyer and passenger are, joined based on the passenger ID. And we want to do another join on the membership using the membership field. The join is going to be between the membership, between the frequent flyer and the new table we created, reward point. And then we want to group by the first name and last name. And then this is another, new syntax that we haven't, seen before. So we are going to create the sum of, points earned from the reward point table. And then we are going to name this as total reward points. Now let me go ahead and create this query. So we are joining three tables, passenger, frequent flyer, and reward point. I'm gonna run this for the first name and last name. We get the total reward points based on the single membership that the passenger has inside of the frequent flyer. Again, remember, each passenger can only have one record in the frequent flyer table, but for each membership in the frequent flyer table, we can have as many reward point records as we want. The next thing that I want you to do is to, write a delete rule so that if a frequent flyer record is deleted, the reward point entries are also removed. This is something that we discussed, previously on cascade delete. Do you remember? So because there is a parent-child relationship between the frequent flyer and reward point, each record in the reward point is linked to a record in the frequent flyer. What we want to do is to kind of, is to create a cascade delete behavior so that if we delete a record in the frequent flyer, table, all of the child records from the, reward point table are deleted automatically. This is called undelete cascade. So we had no action. If you remember, we had set null, and now we have, delete cascade. So what we are going to do is to, alter the table. We are going to drop the constraint on that, foreign key that we created. So if you want to, add this behavior, you cannot modify a foreign key constraint directly. You need to first delete it. You're going to drop it, and then you're going to add it again. So you're going to add that constraint again. You're going to alter the table. You're going to add that constraint again with the same configuration, but in this new constraint, you're going to add this undelete cascade, which means that the relationship is going to be established but this time the behavior is not set by default to no action. No action is something we discussed in the previous episode. In this case, we are explicitly setting cascade as our behavior, again meaning that if a record is deleted from the frequent flyer table, all of the child records in the reward point table are also deleted. I'm gonna let you do this or write this on your own. You can again find the full script using the link I have provided in the description of this video. And that was it. Thank you so much for watching this episode. I know it was a rather long episode, but we now understand the different types of joins. We have a database with some sample data. We executed several queries, each showing us how to make joins between tables. We understood the importance of table aliases, and we're now ready to dive deeper into the next topics and concepts in SQL Server. So that's it for this episode, and I'll see you in the next one.